Hello! In this video, I'll be talking about Logit function and the inverse logic function, which is also called logistic function. Logit function is a function of probability. Probability is a number between 0 and 1, and Logit function of p is defined as log of p over 1 minus p, where this log is a natural logarithm. So the graph of Logit p looks like this. The curve touches y equal to 0 line at 0.5, because if we plug in Logit 0.5, we will be getting log of 0.5 over 0.5, which is log of 1. And if you know the trend, if you know the graph for logarithm, then you know that log of 1 is actually 0. And because the only constraint we have here is p is between 0 and 1, so p over 1 minus p can basically be any number from 0 to infinity. And that is why in the Logit graph, we don't have a lower bound or upper bound. Okay. Now let's move on to logistic function, which is the inverse Logit function. We usually use inverse Logit of a to denote that. In order to get an inverse of a function, we need to create a new variable. So in our case, let's just set the Logit p equal to a, equal to log p over 1 minus p. So the inverse Logit function will be a function of a. And how do we know what's the relationship between a and p? Well, if we take inverse Logit on both sides of this equation, then we will get Logit inverse Logit p equal to Logit inverse a, which is the Logit function we were looking for. And the left-hand side is equal to p. We're seeking a relationship between p and a. And in order to get that, let's take a closer look at this equation. This is so far what we know about a and p. And we want to simplify this and single out p. Let's first get rid of the logarithm. So we take the exponential of a and the exponential of log p over 1 minus p, which will be p of 1 minus p, because exponential and logarithm, they're inverse functions, so they cancel out each other. Alright? And as I said, our goal is to single out p, so we need to do some derivation on the right hand side where we want p to be a linear term. So here's the trick. We can modify the numerator as p minus 1 plus 1, and if we further simplify that, we will get 1 plus 1 over 1 minus p. And let's move this minus 1 to the left-hand side. E to the power of a plus 1 equal to 1 over 1 minus p. And let's take the inverse on both sides. 1 over e of a plus 1 is equal to 1 minus p. So p is equal to 1 minus 1 over ea plus 1. And that will give us e to the power of a plus 1, e to the power of a plus 1 minus 1, which is e to the power a divided by e to the power a plus 1. Okay, here we found the inverse Logit function of a. And usually in the context of logistic regression or binary outcome, we further simplify this expression by dividing e to the power of a on both the numerator and the denominator. So we will get 1 divided by 1 plus e to the negative a power.